Hello, this is Coach Meidmar. I'm here for AP Precalculus 1.7 Rational Functions and Behavior. Um, so when we're looking at this right here, I got this nice little table here that talks about end behavior. So for end behavior, we are looking really at horizontal or slant asymptotes. Okay, so we're looking at some general function. I'll kind of give you some examples with this too. So um, when we do look at end behavior for rational functions for case one here, leading terms have the same degree. That means that if I have some function like y equals x squared plus x all over 2x squared, I don't know, minus 3, whatever it is. Okay, the degree on the top is 2, the degree on the bottom is 2. So that's when we have the same degree here. Our horizontal asymptote says that it's going to be, so I'll write HA for horizontal asymptote. Nothing, no funny business here. We're going to get y equals, we're going to look at the coefficients, the leading coefficients in each of those because we have the same degree on top and bottom. So we have 1 over 2. Okay. The next case here, case 2. I can't even read. Case 2, when our numerator has a smaller power than the denominator. So example here, let's go with y equals x plus 1 over 2x squared minus 3. In this case, the denominator has a higher power. And our horizontal asymptote is going to be y equals 0. Now, the reason for that is because the bottom is growing really, 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 really fast compared to the top. So since they have a faster growth at the bottom, we're going to have a horizontal asymptote of y equals 0. The next case here, case 3, the numerator has a higher power than the denominator. So that'd be an example of y equals, I'll do x squared plus x all over 2x plus 1. There you go. The numerator has a higher power. Our end behavior is going to not be horizontal anymore. It's actually going to be slanted, or it could be parabolic. It could look like a trinomial. So what we do here is we take the power on top and subtract the power on the bottom. So we're going to have a slant asymptote, we're going to call it. So SA for slant, that has y equals 1 over 2x. Why is it 1 over 2? Well, because the leading coefficient on the numerator is 1. The leading coefficient, the denominator, is 2. So that's why it's 1 over 2. Why is it x? We take the power on top, subtract the power on the bottom. So this is our slant asymptote right there. 1 half x. Okay. We call that, and again, this is a little note right here. If the degree is exactly 1 larger in the numerator, it's going to give us a slant asymptote. All right, determine if the rational functions have a horizontal slant asymptote or neither. If the function has a horizontal asymptote, write the equation of the asymptote. Okay, so for A here, we're looking at 3x squared is the largest on the top. 5x squared is the largest on the bottom. Okay, so you can think of it this way if it helps you, is y equals 3x squared over 5x squared. Think of it that way. And what happens? The x squareds cancel out. So we're going to have an asymptote of y equals 3 over 5. That's just a way of thinking how to find these horizontal asymptotes, or really your end behavior, because they could be slant asymptotes. Okay. The next one for B. I'll write down this is a horizontal asymptote. I did not even answer the question. So this is a horizontal asymptote. Okay. Moving on to B. We have a 2x minus 5 on top, and then x squared plus 3x plus 2 on the bottom. If you notice, my leading power on top is 2x, and my leading power on the bottom is x squared. Okay. I guess you can write it like this, 2x over x squared, to kind of think of that, because we're just going to try to isolate just the powers. If you notice, the bottom power is larger, which means as the numbers get larger, like if you plug in a 10, you're going to get like 20 over 100. Okay, it's like 1/5. let's go. You say you have 1,000, you're gonna get like 2,000 over a million. All right, that's a really, really small number. We keep going out further and further and further. It's going to get closer and closer to zero. So it's going to give us a horizontal asymptote at zero. Again, because the bottom has a bigger power. And then for this last example here, for the first example, letter C here, look at the highest power on top, which is going to be a 2x squared. Look at the highest power on the bottom, which is 5x. Higher power on top, we can actually cancel out the squared with this x right over here. So that's going to give me a asymptote of y equals 2 over 5x, because I still have an x on the top, because I just had a squared cancel out with just a single one right below it. So this is going to be a slant asymptote, or oblique. All right, easy squeezy. Now we're going to start to add in some limit statements here just to help us out. So we're going to write a limit statement to describe the end behavior. So just as a reminder, before I even get into the weeds here with letter A, left means that we're going to be approaching negative infinity. Okay, I'll leave that blank for right now. And the right is when we're approaching positive infinity. Okay. All right, so here we go. Now, looking at this first example, my highest power on top is going to be 2x cubed over 6x cubed, which those x cubes cancel out, and this reduces down to 1/3. So my end behavior on both sides will be the same because it's a horizontal asymptote. A horizontal asymptote is going to have the same end behavior on each side because it's a horizontal line. So we're going to get 1/3 for the right and the left. Letter B. I'm going to just kind of write my left immediately. And my right, just so I can get used to writing these limit statements. Okay, so let's talk about this now. We got a high power of 5x squared on top. We have 2x cubed on the bottom. So I'm really just looking at 5x squared over 2x cubed. Those are the highest growth parts of the polynomials. So I have bigger on the bottom. So I have a higher power, which means that when I plug in bigger and bigger and bigger numbers, I'm going to get closer and closer to zero. So we have a horizontal asymptote. This doesn't really equal zero. I don't want to write incorrect things. It doesn't really equal zero, but that's going to give us a horizontal asymptote of zero. I'll write that. Horizontal asymptote, y equals zero. Okay. Again, horizontal asymptote is going to have the same end behavior left and right. Okay. Last one here with talking about this end behavior. Again, I'm going to write out the left and the right. Okay, so if I'm looking at the highest powers here, top is going to be negative 3x squared. Bottom is going to be x squared. So I'm going to get y equals negative 3x to the fourth. Did I say squared? I meant to the fourth. Okay, and this actually reduces down to negative 3x. So my horizontal asymptote is negative 3x, which is that line right there. It's got about a slope of negative 3. This helps me for the end behavior because I can see where the slope is. Okay, so asymptotes, that means that the function for horizontal asymptotes or for slant asymptotes, that the function is going to hug the asymptote towards the end. So if I look, the left end behavior is up. You can kind of see how the end behavior right here is up. I'll undo that so that doesn't look weird on the keyed notes. Okay, so it's going to be up. So it's positive infinity. Look at the end behavior of that dotted line to the right. That's going to go down to negative infinity. Okay. Now, we have some graphs here. So let's look at these end behaviors. These are already graphed out rational functions for us. So if I'm looking at the end behavior, I have a horizontal asymptote here at y equals 2. Since the horizontal asymptote is y equals 2, my end behavior is the same on the right and the left, which is both going to be 2. So my left end behavior, this function, did they give us a function here? We'll just call this function, I don't know, f of x. I'll label it because I should fix that for the next time we do these notes. And the right end behavior is going to be the same. And for E here, what I got going on here is I have a horizontal asymptote at y equals -1, which means that my end behavior on the right and left is going to be -1. So the limit as x approaches, again, this doesn't have anything. I'll just call this h of x, just so I have a name for it. As we approach negative infinity of h of x, it'll give me -1. I don't know what just happened when I wrote that. All right, easy squeezy, lemon peasy, right? Hey, last part here, and I talked about this slant asymptotes already. This is really just saying stuff that I've already mentioned before. If the power is greater by 1 on top, we're going to have a slant asymptote. That being said, which of the following rational functions has a slant asymptote parallel to the line y equals 1/2 x? So essentially, I want to look at the powers on the top and bottom. Whenever the top power is bigger than 1, and the coefficients simplify to 1/2, I'm good to go. So if I look right here for 1, that's going to give me a slant asymptote of y equals 1/2. Close, but it ain't 1/2 x. If I look at g of x, we actually have a larger power on the bottom, so that's going to give me y equals 0. Ooh, if I look at h of x here, that power on top is bigger by 1. So it's y equals, the coefficients are 1/2, and x squared over x. The x squared cancels out with the x. I'm left with just an x. So this right here is our answer. And just for giggles, let's go ahead and talk about k. K is also bigger, but it's bigger by 2. So it's actually going to give me a parabola for a not slant asymptote. It'll give me a parabolic asymptote. All right, and that's going to wrap up our notes here for 1.7. Don't forget to like and subscribe.